product of v and v is equal to the magnitude of v squared. Well, the magnitude of v, well, that's the square root of v1 squared plus v2 squared, yes? Because that's just the magnitude. But if we square it, well, that means the square root is gone, yes? So it just leaves us with v1 plus v2 squared. And this is really talking about our v1, the vectors, the components v1, v2. We get this here. Now the dot product of v, and I'll scroll down here, because we said v dot v. Well, that's going to be v1, v1 plus v2, v2, because we're multiplying the first components by the second components. And we get this here. Well, that's, well, v1 times v1, well, that's just going to be what? v1 squared. And v2 times v2 is just v2 squared. So those work out to be the same thing. So if I really wanted to, instead of doing, because I could use the magnitude formula, or I can just take the square root of v dot v, which would be the same as the magnitude of v. So we can use that however we want. And then we can multiply through by a constant, multiply a dot product by a constant, but notice the constant is only affecting one of the vectors. It's not affecting both. It will only affect one of them. Now the first thing we're going to do is actually do some dot products, multiplying or using the dot product on vectors. And when we do this here, well, those go away. And again, we're going to multiply the first two terms together. So we would have what? Plus. Well, 4 times 2 is 5 times, which gives us that's it. Now, if we look at this one here, what would we do? Yes. That's it. 23 and 0. And lastly, if we did this one here, I think y'all pretty much got the hang of this, we would have 0 times 4 plus 3 times negative 2, which would be 0 minus 6, which would give us negative 6. And that's it. That's mainly all we have to do to find the dot product. Now, the angle between two non-zero vectors is the angle theta. 0 is less than theta is less than pi between their respective standard positions, as shown in the figure. Now, the angle between two vectors is really given to us by this formula here. Cosine of theta is equal to the dot product of u times v over the magnitude of u times the magnitude of v. Well, two non-zero vectors, because if one of them 0, it really doesn't tell us anything. Because if you remember, the 0 vector is just a point. So if we have a 0 vector, well, two 0 vectors, well, that's just a point. We don't have an angle. And even if we just have a 0 vector and a non-zero vector, well, that's just a ray. We don't have an angle. We don't have an angle made up from those two. So we have to have non-zero vectors. And really, all we're going to do is use the formula that cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. So really at this point we're just going on and simplifying and just plugging things in. Now u dot v, so we're using u and v. So on top we're going to have what? plus 4 times 3 plus 3 times 5. That's just, that's our dot product. Okay, now we're going to have it over the magnitude of u and the magnitude of v. Well, the magnitude of u is going to be plus 4. And the other one's going to be 3 squared plus 3 squared plus 5 squared. Extend that a little bit so that we can see this here. So we look at this here. Yep. Cosine of theta is equal to, right, because 4 squared plus 3 squared, so it's going to be 16 plus 9. A little higher. You good? So that's what we have on bottom. Now on top we'd have 4 times 3, 12 and 15. Now we can simplify this a little bit further. Cosine of theta is equal to, well, 12 plus 15 is 27. Right, because 16 plus 9 is 25, which is, because the square root of 25 is 5. 9, we cannot take the square root of 34. Because 34 by itself doesn't reduce, because the next closest one would be 36. Now 2 goes into 34, it would be 2 and 17. Well, 17 is prime. So it can't reduce, and it works out that this is as simplified as it gets. Questions on this here? Now, at this point here, we normally talk about, well, we need to rationalize the denominator, yes? Well, what do we need to find? What are we actually finding? We're trying to find what? The angle, yes? I mean, we can rationalize that if we want, but it's not going to change anything. Because have we gotten to what we're solving yet? No, we're still trying to find what? The angle. Well, if I'm going to get at the angle, I need to do what to both sides? I need to take cosine inverse of each side. And luckily with our calculators, either one, any of the calculators, most of the calculators that we have, is not really going to bother it if there is a radical in the denominator. So the angle that we're looking at here, the angle between these two vectors is 22.17 degrees. And that's it. That's all we have to do to find this here. Questions on this here? We good with this here? So they plugged it in and got 27 here. And then they put it in radians, or if we could convert it over to radians, that's fine. But it's the same thing. And that's it. Now, rewriting the expression for the angle between two vectors in this form, u dot v is equal to the magnitude of u times the magnitude of v cosine of theta, is an alternate form of dot product. Products produces an alternate way to calculate the dot product. From this, you can see that if you can see that because the magnitude of u times the magnitude of v are always positive, u dot v and cosine of theta will always have the same sign. Because, again, magnitudes have to be positive. Cosine between 0 and 180 is always going to be positive. So if it's in the top coordinates, u dot v has to be positive, as well as the other direction. Also, it's kind of saying Yeah, will always be positive. Because mainly that's what we're looking at. Now, there are 5 possible combinations that we could have of these here. Is that U and V are in opposite directions? It's 180 degrees. And if that's true, or is equal to pi, cosine of theta equals -1. So it's saying it's going to be in opposite directions. U dot V, if we get negative. Here, it's between 0 and pi over 2. Pi over 2 and pi, so it's between 90 and 180. We're going to get this here where cosine's between this is an obtuse angle. If it's equal to 90, if it's exactly equal to 90 degrees, it'll equal 0. The dot product will equal 0. Acute angle, and if it's same direction, it'll just equal 1. Cosine will equal 1. Now, most importantly, they'll talk about orthogonal. If you're wondering what that word is, it's orthogonal. Orthogonal vectors. 2 vectors are considered orthogonal if their dot product is 0. If the dot product of the 2 vectors is 0, then they are orthogonal or perpendicular. Perpendicular and orthogonal are kind of interchangeable, or essentially mean the same thing. There are probably some cases, not that I can think of off the top of my head, that the meanings might change. And it's most likely if we're dealing with kind of different number systems or different concepts. But most likely, they're essentially the same thing. Note that 0 vector is orthogonal to every vector u. 0 times u is 0. I need vector components. So we'll stop there. We'll do